Hello, everyone. I hope you are doing well. I am Jawad. So, before what we did, we in the previous section we installed the KVM Linux on the ESXi, and it was ready, and the libworld daemon was running. Right? System CTL status libworld. Okay, it's running. No, it's not active. Let's start it and enable it. Okay, and let's see the status. So right now this daemon is running already. Our service is running and it is ready to create the VMs and all stuff. But before that, we need to create the bridges. We need to have the networking available for the VMs. Correct? So how this VMs will basically going to communicate? For that we need some kind of communication, right? So here the bridges comes. What are Linux bridges? You can imagine you have several computers at home and you want to them to talk to each other. Now, if you have a physical device like a switch or a small hub, you could plug them in all and you will be able to communicate. A Linux bridge is like that switch, but it's a software based. It lets different network interfaces on the Linux systems connect and communicate if they were physically connected on the same network. This is going to be noted that it should be on the same network. So essentially, it's a way to manage traffic flow between devices or network segment, you can say, right within your Linux system. So I hope it's clear. Now let's go to the bridge types. Actually, technically speaking, there is no bridges type. Um, we are not looking at different flavors or varieties, okay? It's about how you configure or how you use those Linux bridges. For instance, you might use a bridge to connect virtual machines to each other and to the internet, creating a little isolated network that's all digital, right? Or you might use the bridge to segment a physical network, right, into a logical section for better management and security. So it's all depend what type of configuration you are doing. It's not actually types, it's just the way you are configuring the bridges. So what is the role of this network bridges in the Linux world? It's like, for example, we segment the network. It's like having a VIP section at the concert. You keep certain traffic its own section of your network away from general admission crowd, right? It's just a layman example. And what is traffic management? Think of a bit like you can think like a cop, right? Which is who is helping to direct where the traffic to go, and he will just apply some rules about where to allow and where not to allow, right? So this is what traffic segmentation is doing. And virtualization support, sorry, this is a spelling mistake here. It's like you are running different virtual machines or container. A Linux bridge here plays a vital role. It's connect those virtual environment to each other and also this virtual environment to the physical network. So it's just like how the airport shuttles get you from one terminal to another and eventually to the outside world. Isn't it so cool? And also the second last is simplicity and flexibility. Since it's all software, so it's setting up Linux bridges just like you are downloading an app instead of buying a physical device. So you got a very much flexibility without extra hardware clutter, right? And performance, despite being software, Linux bridges are really pretty efficient. You can say they are like in electric cars, quicker and cleaner, right? So I hope you got the idea about the bridges. Okay, now we discuss about the port map and Linux bridges, because already we were discussing about the port group. The functionalities look like similar. You see, here is a VM and here is a bridge. Imagine the same bridge we have normal in our roads. It is doing the same function. It's connecting this VM to this VM. But you have to notice this one is in the same subnet, right? And it is connecting this one to this VM. However, on the V switch, it's also doing the same kind of thing, but it's in a different way. You can see here, it is also called template. Why? Because whatever the policy I define in the template, it will inherit this port, the virtual port of the VM will inherit. And for example, what is the traffic shipping policy? What is the security? The VLANs should be allowed. It is trunk port or what? So this kind of setting will be inherited here, and according to that, it will connect some kind of. But it's also doing the bridging work actually, but in a different way. You can think Linux bridge as a traffic intersections. Imagine you have a busy city with a lot of roads and intersections. Those intersections are crucial because they help to manage how the cards, which in our cases are the data packets from here to here, move from one street to another street, right? So Linux bridges are like this intersection in our city. They make sure that how the cars can smoothly turn or go straight to here or somewhere else, heading to the destination without crashing in each other, right? So this is the beauty. So if you talk about the port group, port group thinks about how you use the GPS on your phone, right? You're trying to find the specific place like a coffee shop. Your GPS port map just do not throw you into the city. It's and it's instead it's give you turn by turn directions, making sure until you arrive to your destinations. Okay, in the computer network city port map, ensure that your request gets directed to the right street. Not it should be directed maybe here and instead it's directed here, right? So this is the beauty of this. And how they work together, Linux bridges make sure that the overall traffic flow is smooth. And while on the other hand, what you call it, overall, what I mean to say that they make sure that overall traffic flow is smooth, and while the port map provides a specific direction needed to reach the exact destination. Okay, so this is what is about port map and the Linux bridges. Okay, so bonding and its flavor. What is bonding? Bonding is nothing like you do aggregation in the routers, you make a lag, right? In the Cisco, you make a port channel. Similarly, in the Linux world, you have the bonding. If you don't have idea, it's just imagine you have two or more internet connection at home, right? And if you could combine them to go get faster, then is this is the bond. So bonding does in the Linux environment the same. It allows you to take multiple interfaces and treat them as a single link, right? So this is what bond. This is as the name implies, right? It's like banding together with the friends to form a team, and that's stronger than any of the members individually. Think like that as a layman. So we have different flavors of the bonding. Mostly, this one is most popular round robin and active backup or the module 4. What is that? For example, round robin is like really a race mode. Packets are sequentially across each interface. For example, first it will go to the Ethernet 0, then Ethernet 1, then Ethernet 0, Ethernet 1, like that in a round robin fashion. This is RR is round robin. And active standby is the only one of the port will be active, and if the other fails, the other will take over. but there will be no increase in the bandwidth, while in this case it is an increase in the bandwidth, right? And you have also kind of mode 4, which is LACP, because it's based on the IEEE 803 802.3 AD. It's combined the interface to increase the bandwidth and also provide the redundancy. All right, but in our case, we are not going to use bond. I will tell you why later on when we will discuss the topology. Okay, and you will see if you want to configure any one of those modes, you can just in the bond file, you can just give this option mode and you can select the value, and this memon is equals 200. It's going to be different value. It's what is this? It's basically media independent interface monitoring. It is the way the system to keep an eye on your health that of the bond network that and is checking at a regular interval. Here it is in 100 millisecond. So it means it detects a failure if one of the links fails, or for example the cable is unplugged or goes down. The bonding driver can react accordingly. Okay, it can shift from active to backup immediately. And it will remove the failed link from the bond to maintain the network connectivity through the remaining healthy links. So this is really beneficial for maintaining the reliability and performance of the bonded network connection. So I hope this is clear. Now we are in this topology. We will be having this topology. You can see we have on this lower side, we have ESXi port groups. Okay, one is vSwitch, on which two VMs are running, these DNS and vCenter. It is assigned to this by default VM network port group. I have already discussed in the previous videos what is VM network port group, which is default in the ESXi. I will repeat. This one data port group we already created together in our previous videos. And this one is connected to the DNS. However, this VM network port group is connected to the external world and is going to the internet. Let me open the other topology so it will be more clear. I hope this is bigger. All right, so see in the where it goes, my mouse, sorry. Okay, I think in the pane is better. This is the hypervisor, and this layer, as I told you, is the here we have vCenter here also, which is having external connectivity here, and also this one. And then DNS, one of our VM is having this one also. So DNS having two ports, one this one and one this one. All right. And on top of the hypervisor, we have another hypervisor running, which is called KVM. And in this KVM, we will be creating three bridges: outband management bridge, in-band management bridge, and trunk bridge. What outband management will do it? It will talk to the external world, internet. For example, if I have to download, communicate anything, I can communicate. So the VM will be connected to the outband bridge for the external communication. There will be one more bridge, which will be in different subnet. You can see here the subnets are different. For this one is in-band. In-band is why, for example, I will create EVNG for the lab simulation, and that elimination I have also, you see, the runner machine here. So if when I will be executing CI/CD pipeline, or in easy term, you'll say if I have to execute some code, it will be executed here on the runner machine, and it will communicate with the devices inside the EVNG. So it will communicate with the help of in-band management port. Okay, not the outband management port. So this is why we create another bridge. I will also have a controller which will be acting as a router, layer 3 devices. So for example, every this bridge or any of the VLANs created inside here will be giving a gateway of to the router, so I can also leak the routes from this one to here in order to intercommunication later on. We will be using for the SDN. We will show later on the in different video series. All right. Trunk bridge, it is acting like a trunk port, you can say, like this data port, right? This data port is also configured to accept all the VLANs. So this is here I configured. So inside the Eve NG, when we will having different nodes, Cisco routers, Nokia routers, Juniper routers, which will having VLANs, and if they want to communicate with the external some other devices, maybe we will have the NMS NSP running here, and if they want to contact, they will go to the controller, and the controller will talk to the NSP or NSO word. All right. So we configure the network bridge for a trunk port, which will carry the VLANs traffic. And you can see this one is all going to data port. This bridge, these two bridge, the green color is going to this ESXi. It is mapped internally. You see E1, 0. What is the E0 and E1? They are the ports of the KVM. Not physical port, logical ports, right? VNIC. Okay. VNIC 0 and VNIC 1. Okay, and you see here we can make the bonding. Okay, why we cannot make a bond here? Because for the bonding, it is the requirement that the link type should be same, right? Here we are using D switch and here we are using a V switch. If I migrate in the future this V switch VMs to this data port group or into the same D switch, then I will be able to easily load balance it. If I make it active and standby, then either one of this Ethernet one will work or this one will work. So that is the reason I'm not going to do the bonding, but I will show you the example of bonding, that how we can configure it. All right. So I hope till now is all clear. These are the VMs. Again, I will repeat, these are the VMs. The same VMs here, also here, but you can see it's only the in-band management. And this is for the out-band management. I'm repeating it. And this is trunk bridge, which is separate for the VLANs communications. And that is mapped to the data port. Okay. Now I will go back to the slide we were discussing here. Okay. Now we have to go. What is this? I think I did not tell you about let us discuss about this one first. What is IP forwarding? We need to check that the IP forwarding is enabled or not, because what is like this file is like a switch inside your Linux system that controls that how the handles the traffic. When it is, if it is 0, if you see the value 0, it's mean it's like a regular computer receiving data, mean it's not passing to any other devices. So if IP forwarding will be turned off, right? So we need to turn it on, so it can be acts like a mini router, taking data comes in one network and sending out to the other bridge. So this is very crucial. We need to check it. Let's check it together. cat/etc/ what is the command? I always forgot. What is and IPv4 slash why? Okay, sorry. I think it's wrong. Okay, so it's already one. So we do not need to worry, because turning IP forwarding is really essential for any system that we need to route. And as discussed here, we need to talk to the bridges, right? Otherwise, it will be stuck here. It will not go outside. Okay. And what was the second point? It was the second point was SE Linux. SE Linux is a security layer which is a part of the Linux systems. It's basically adds an extra protection by enforcing strict rules that how application and system process can access resources on a computer. All right, these rules must be detailed, and how it works actually, it has three modes: enforcing, permissive, and disabled mode. If it is in enforcing mode, it will block the unauthorized access. And if it is in permissive mode, it won't block, but it will log all the violation. And lastly, it is disabled, means it's all turn off and there's no security. So basically, you can say that it acts like an additional layer of security and helps you keep your system safe from unauthorized access. But the thing is that we know it's already secured, and I don't want to. Let's see the status. The status. All right. Current mode is permissive, and we should make it disabled, right? Because it should not be uh, enabled. So we can make it disabled. This is the cat. Here is the directory etc se linux config cat etc slash linux config. So you see what is the file se linux is equals to status. This is wrong. It should be disabled. It should be in one of those values. All right. So I will go on the vi, control shift, and I will make this a build. So also you see that what I was telling you is giving the types of the three different modes. However, it will not take effect because I need to reboot it. Now it's okay, but it will not be reflected. Still, it's enabled, right? So we need to disable it. I will reboot it later on. No worries. And before that, we need to. I hope I discuss all. Yeah, we discussed this. We discussed port map, bonding, lab topology we discussed. And the last one, we will go for the word host validate. Okay, so everything is passed. This is nothing to worry because this one, as I remember, is platform. Yeah, your processor, it's has some security features. It should support that one. Maybe this processor is not supported. You will find on the process something called Pro, which has the security feature enabled, but we don't need it. It's fine. All right. So this one is done. Now we need to configure the interfaces and what you call it, bridges and bond. I will show you what is the bond. Let's go here. Okay, first of all, I will configure this one. I will show you this. Where is the CD? etc sysconfig script. Okay, I have only right now two files. I will do manually we can do with two options, with the network manager, with the NMCLI, and also with the manually. So I will disable the network manager, but let me configure first because it's already system CTL status. Okay, it's running, but network will not be running. Yeah, I have to install it, but I will do later on. It's not the case. VI. Okay, I will remove this one. Okay, you can see here this interface. I put it temporarily IP, but I will remove it because it's for just temporarily. What's happening is saying that type is Ethernet. This is a device, and root protocol is none because I don't want to put any IP here. That's why I'm putting none here. If you are configuring bond, you just need to put here bond, okay, and slave yes here. NM control no means it will not use the network manager. All right. I am here specifying, usually it is not needed, but I am defining this bridge. It's mean that by default, this bridge will be used for, will be mapped to this interface. But it is not, it does not mean that the other bridges will not work. It doesn't mean this, right? So, okay, this is done. This is the first interface. Okay, I configure this E0, which is in our case is ENS 192. Now let's configure the other one. Okay, this is the same because I'm not putting the in the pond, so I am just commenting it the same value, and I'm using this bridge for this port. Remember, I told you that our system plan is different. For all the tag or traffic, in-band bridge or trunk bridge traffic will go on this port, and the outband management traffic will go on this Ethernet port. All right. So this is the reason we are segregating that the traffic over two ports. We are not combining. Why we are not combining? Again, I will repeat, because we are using different kind of switches. The uplink is different here. It should be same kind of uplink. All the properties should match to the leg. Like, I mean, in the router also the legs should match, right? To the far end and to the near end to work properly. Similarly here also the concept apply if you are coming from the router background. Okay, so two interface is now configured. Now what's the next? Maybe you would be thinking, what is this cat? Uh, Hot plug, no. Yeah, this one is basically instructing to the system that do not attempt to configure or manage devices that are added or removed when the system is running. It's the way, hey man, do not auto adjust or try to accommodate what you say, the new network devices on your own. All right, we will handle such changes manually. So this is what it means. What next is bond. I will copy paste here just to show you, but it will not be used. Okay, this is master. Remember I told you the values, different values. I will come back here. You can set it 1, 0, 4, or whatever you want it. All right. But I'm not using this one right now. But I just show you the example here. And if you want to do in future, you can just show you here. This is the bond configuration, and you can change the value according to your need. But here you see, if you are using bond, then I will put the bridge here. But in our case, I put this configuration on the here. All right. So I hope this is clear. This is not in use. Bond is created. Now let's create the outband bridge, where it is here. Band dash mgmt. The same name, mgmt. Yeah, that's correct. I hope it's all clear. This is the device on boot. Yeah, you should do the boot. And the bridge, I did not discuss here. Okay, I think it's missed. But no worries, I will explain here to you. Okay, this is how we created the bridge. This is the device, and it should boot on when you boot it. It should be on. NM control means I will not use the network manager. Instead, the manual script, the network services will be used. Type is bridge. Delay is 0, means is setting the bridge configuration. Essentially mean that as soon as the bridge receives the data, it will forward this data to the correct destination immediately without holding it onto it for any other amount of time. This is the and then we have boot protocol can be static, none, or DHCP. I am setting a static because I am configuring here the IP. All right. Hot plug I have already explained to you. So this is bridge is ready. And how it will be mapped? It will go to the traffic. This is where is the topology? Okay, I just configured this one, and how it will go to the Ethernet ENFS 192. I have already. Let me again show you. So it is very clear. You see, I have already mapped here bridge. So that's why how the traffic will flow to this one. E0 is already accepting. Okay, this bridge is binded to this one. Actually, usually it's not needed, but I have manually defined so the KVM will detect it. All right. What next is the in-band. Here we go again. I am now defining in this bridge. Okay. In-band. We are in-band. Type bridge, static. Yes. And this. I told you that I think I did not mention here. This in-band will be having a VLAN, which is VLAN 10. It is not the same bridge like this one, trunk bridge. So it will be having a VLAN. So I need to also define the VLAN. So what I will do here, I will go here on the VLAN and I will create the VLAN 10. If you see here, it's telling I should put root protocol none because whenever we are making some VLANs, it should be none because we are not assigning any kind of IP or it is not DHCP. And VLAN will be yes. And this is the key. Physical devices you will not configure anywhere else. It should be only in the VLAN files. For example, you create 10 VLANs, it will be given some physical device. So it can be bond 0 also. If you are using bond 0, it will be here bond 0. But in our case, as I told you, we are using separately. So it will go to the ENS224. Where is ENS224? Here is this one. So this one will go to here and to this. So 10. So if some VM, for example, this DNS is talking VLAN 10, which is talking, we will show you, demonstrate you all the ping. Don't worry. So this is a VLAN 10 and it can communicate with any other VLAN which is in the VLAN 10. Okay, so that's why we make it in band. So it can communicate with this DNS in the VLAN 10. I hope it's clear. Okay, and now what else? Now this is done, and now this is the last bridge which we will creating. You see FG, PR, trunk. Spelling is correct. Yeah. Okay. All right. So now this bridge is trunk. Root protocol is none. Now this will accept all the VLANs. For this one to run, where is the topology? Here. Here you have to define some VLANs. Here some VLANs inside the EAVNG, the nodes which will be running. If they want to communicate, for example, VLAN 20, you define here VLAN 20, here VLAN 20, and it will able to communicate. All right. So this is we defined this bridge. So now we have this bridge is ready, this bridge is ready, this bridge is ready. These two ports are ready. Everything is ready now. Ready to communicate. Now our okay, I have already rebooted the system. So now it should be you see now it's disabled and all the bridges are now configured system CTL. I have disabled it. The network manager, I hope it's still disabled. Yeah, and I will see the network status is loaded because I already installed those. For that, you need to install the network scripts, which is already installed. Okay, it's already installed. This is for the network services. As I told you, I make the approach of making manual. All right, these are all configured. You see, 192 is up, 224 is up, bond 0 is down because I did not configure it. I will just show you. Out management has this IP 200. Trunk is also up. And you see the VLAN 10 is bind to 224 interface. And in band is also up. And let's see the other way. You can see this two interfaces, and to see the bridge, what was the command? Yeah, I can see IP-link show. It will show you the up. It will show all the details, MAC address, and other settings for that specific bridge. So what we learned today, we already have created all these bridges as I told you before. And in the next video, we will be spinning up our first VM, which is EVNG. And then later on, we will be, oh, 1 second, sorry. I forget to tell you about this one. So here you see, remember we create the port groups. This is the port groups here. Summary, where is the ports? You see the PM. VM host, and the DNS is there already. If you go back on the diagram, I will go back into the diagram here. Here, you see, I told you one of this trunk is Ethernet 1 port is bind here. If I go to that here, no, it's not showing here, but I can find this is all trunk allowed, right? And DNS is also sharing. Here you can also see VMs. Which VMs are sharing? You see DNS and this VM host is sharing this data port group. And if I go here and I click VMs, I can see 3 VMs, which are these DNS, vCenter, and what else? This KVM. This one we have discussed already in details how to create in the previous video series. So coming back here, so then after this EVNG, we will be setting up this runner machine where this will be communicating with the the nodes inside the EMG. Ubuntu will be acting like what you call jump host server or the remote desktop client. Controller will be the router. Okay. So I hope it's all clear for today. Our bridges networking is set up. Everything is ready. So let's meet in the next video. Hope you enjoyed it. Goodbye.